So I've got this calculating trig values. I've got the point 2, 5. So if I graph that coordinate point, I would go over 2, and then I would go straight up 5, making a right angle. I could connect that point. Look, I'm starting on the positive part of the x-axis, and I'm going in counterclockwise direction. I got a nice angle right there. Well, I don't know what my hypotenuse is, so I got to figure that out. So I'm going to use r for my hypotenuse for reasons you will see soon. 2 squared plus 5 squared. So r equals plus or minus the square root of, let's see, 4 plus 5, that's 29. And I'm going to use just the positive case. I could use the negative case, and you're going to see that in a minute, but the hypotenuse, the r, is always going to be a positive value. Now that I've got that, I can find sine, cosine, and tangent. So the sine of that angle is going to be the opposite over hypotenuse. So that's 5 over the square root of 29. Oh, I got to rationalize my denominator. So I'll multiply top and bottom by the square root of 29. So get 5 squared roots of 29 over 29. Same thing with cosine. Cosine is going to be adjacent over hypotenuse, so that's 2 over the square root of 29. Rationalize my denominator, I get 2 squared roots of 29 over 29. Tangent is going to be opposite over adjacent. So opposite over adjacent is 5 over 2. Now let's do the reciprocals. I'll start with cotangent. 5 over 2, flip that upside down, you get 2 over 5. Secant. I need to flip cosine upside down. Now I could do this one, but there's a lot of stuff going on with that one. And if I flip it, I'm going to end up with a square in the denominator, and I got to get it out again. I don't want to do that. So instead, let's use this one and flip that. That'll get us just square root of 29 over 2. Oh, neat. I don't have to do any simplification then. Last one is cosecant of theta is the square root of 29 over 5. Done. All 6. For this one, we've got 2 negative values. So I've got to graph a coordinate point that's down there in quadrant 3. It's going to go -4. So I have a negative side length for my triangle. Oh, I told you it was coming. And another negative side length for my triangle. Ooh. Now, the angle that we're dealing with is actually all of that. Because remember, our angles are always starting at the positive part of our x-axis. Now, inside of the triangle, you get this cool little angle in here. It's called a reference angle that we're using to refer to what's going on with our actual angle. So theta is the actual angle, and that alpha is our reference angle. It's not the same as theta, but we're using to kind of get an idea of like what would be going on inside of this right triangle. I got to figure out what my hypotenuse is, so that's a quick Pythagorean theorem. So r squared is going to be -4 squared plus -7 squared. Be careful that you keep those both as parentheses so that when you square them, become positive. So we get 16 plus 49, which is 65. So r is plus or minus the square root of 65. That is 13 and 5, so yeah, no, that can be simplified. And we're just going to use the positive case for our hypotenuse. Our hypotenuse is always positive for reasons that are coming next chapter. All right, now it's going to be the same tricks that we were doing before. So the sine of our theta is going to be our opposite over our hypotenuse. So -7 over the square root of 65. Simplify that thing, we get -7 square roots of 65 over 65. Cosine of theta is going to be our adjacent side over our hypotenuse. So that's negative 4 over the square root of 65 equals negative 4 square root of 65 over 65. Finally, we got that tangent theta equals our opposite over adjacent. So our opposite side is 7 and negative 4. So we get negative 7 over negative 4. Well, that's really just 7 over 4. Interesting. Tangent was positive, but the other two are negative. Huh. Cotangent of theta is going to be tangent upside down. So that's going to be 4 over 7, just flipping tangent. Secant will be cosine upside down. I don't want to do that simplified one. I want to do the one before it because that'll be just a little bit easier to work with. Square root of 65 of negative 4. And cosecant of theta is going to be the reciprocal of sine, which will be the square root of 65 over negative 7. All set. These ones I really struggle with keeping straight, so really be careful with this one. So I want to find all 6 trig values when the theta equals 90. So notice that I'm not giving a side length for this one. We can use whatever we want for our side length. It doesn't matter because with trig ratios, regardless of about how big our triangle is, if it gets really small or really big, our trig ratios are going to work the same. That's what's cool about those ratios. They kind of simplify and cancel. So I'm going to use something simple. I'm going to use 1. So I'm going to grab this point right here, and it is at 0, 1. Now, I've got to figure out sine, cosine, and tangent for that thing. Now, we know, kind of like looking at what we were doing before. I'll pull up this example. No, I don't want that example. Let's go back to this one with this 2, 5. Notice that this 5 and this 5 are being kind of the opposite side. Same thing here, tangent, 5 and 5. So that is our opposite side. Our hypotenuse is something going on with these two being squared and added together. So can I use that same sort of idea so that this one is opposite and this one is adjacent? And then to figure out the hypotenuse, r, I would just do square the opposite and square the adjacent. So that would be 0 squared plus 1 squared. So r equals plus or minus the square root. 0 squared is 0. 1 squared is 1. And we just square root 1, which is just 1, which is square root of 1 is just 1. And we also want to make our r, our hypotenuse, positive. So r equals 1. And like, remember, I'm doing 0 and 1 because it doesn't matter if I used a bigger value or a smaller value. Things would just cancel out and simplify. So sine is always the opposite side, which seems to be this second value, over our hypotenuse, which is a nice value of 1. So sine is just 1 over 1. Okay. Cosine is always going to be our adjacent side over our hypotenuse. So our adjacent side is 0. And our hypotenuse, again, is that r value, which is just 1. So that's just 0. And the sine is 1. If we go after tangent, tangent is our opposite side over our adjacent side. So opposite and adjacent is 1 over 0. And that doesn't work. That's undefined. You can actually check that in your calculator. If you want to, you can pause the video and pull up your calculator, but type in the tangent of 90. I don't want thetas here, I want 90s. If you type in the tangent of 90 degrees, you'll get an error because you can't do that. Sine of 90 degrees, cosine 90 degrees, tangent of 90 degrees. Okay, let's do cotangent of 90 degrees. Well, that's going to be the reciprocal of tangent. So that is going to be 0/1, which is okay. We can do that. That is just 0. If you try to type this into your calculator, you will still get an error because you have to type it in as 1 over the tangent, and it's going to try to find the tangent of 90 and then blow up. So it's not going to quite get to that 1 over part. So it won't be able to flip the thing that it can't do. Next, we could do secant of 90 degrees. So that's going to be cosine flipped upside down. So that 0/1, if we flip that, we again get that 1/0. So secant of 90 degrees is also undefined. If we go after the cosecant of 90 degrees, ooh, that works because it's 1/1, and you flip that, it's still 1/1. So we get 1. These quadrantals are very tricky. When it's landing right on the axis, our triangle flops straight into a flat line, and it's really difficult to keep it straight. So if you get everything else, but this is the thing that gets you, don't worry. We'll be continuing to work with these quadrantals and be adding more infrastructure to help us work with these problems. But that's it for today. Thank you for watching, and have a good rest of your day. Bye-bye.